Hey, welcome to my channel. Today we are going to explore one of the most fascinating mysteries of the universe, time, and the possibility of traveling through it. Imagine a journey where past, present, and future are not fixed, but part of a vast, intricate web that governs everything in existence. It seems to me that understanding time is essential, not only to physics but to understanding ourselves and our place in the cosmos. Let us embark on this journey together and consider what it truly means to travel through time. Time, as we understand it, is not merely a sequence of moments, but a dimension, much like space. It is woven into the very fabric of the universe, and it governs every motion, every event, every change. To comprehend time, one must first consider space. Space and time are intertwined, forming what we call spacetime. According to Einstein's theory of relativity, the flow of time is not absolute. It depends on speed and gravity. A clock on a fast-moving spaceship will tick slower than one on Earth. A clock near a massive object, such as a star or a black hole, will also tick slower than one far from its gravitational pull. This effect is called time dilation. It may sound like science fiction, but it has been observed in practice. Atomic clocks on satellites in orbit around Earth run slightly faster than clocks on the ground, because the gravitational pull is weaker in space. One cannot ignore that the universe itself has a beginning, the Big Bang. Time as we know it began with that event. There was no before, for time itself was created. The universe is expanding, stretching the fabric of space-time, altering the flow of time in subtle ways across the cosmos. Time travel has long captured the imagination of humans. The laws of physics, as we understand them, allow for certain theoretical possibilities. One is time dilation, which I just mentioned. If a human were to travel near the speed of light, they could experience years while centuries pass on Earth. This is known as forward time travel. One can imagine a spaceship traveling at 99.9% of the speed of light. For the astronauts aboard, only a few years would pass while decades would unfold on Earth. They would return to a world that has aged far beyond their own perception. This phenomenon has profound implications, not only for science, but for our understanding of life and aging. But what about backward time travel? Here, we enter a more speculative domain. Einstein's equations permit the existence of closed time-like curves. These are paths through space-time that loop back upon themselves. They could, theoretically, allow an object to return to an earlier point in time. One can imagine, for example, a massive rotating black hole creating a region where time loops back. However, formidable obstacles exist, such as the formation of singularities and paradoxes. One must consider the famous paradoxes of time travel, such as the grandfather paradox. If you travel to the past and prevent your grandfather from meeting your grandmother, would you cease to exist? Such paradoxes suggest that nature may prevent backward time travel in ways we do not yet understand. It seems to me that the universe has built-in safeguards that protect the sequence of events, preserving causality and preventing absurd contradictions. Time has a direction, what we call the arrow of time. We observe this in entropy, the measure of disorder in a system. The second law of thermodynamics tells us that entropy increases over time. Eggs break but do not unbreak. Stars burn fuel but do not return to their original gas clouds. This unidirectional flow is what gives us the sense of past and future. Without it, cause and effect would be meaningless. The arrow of time is intimately linked to the universe itself. As the universe expands, entropy increases. Were the universe to contract, perhaps time would reverse, but there is no evidence that this is possible. Thus, the direction of time is bound to the cosmos. One cannot help but wonder, if the universe were a movie, we would only ever watch it forward. The past cannot be rewound, at least according to everything we currently understand. Some theoretical physicists have suggested the possibility of wormholes, tunnels through space-time connecting distant regions of the universe, or even different times. These solutions exist in Einstein's equations, but they require exotic matter with negative energy to remain stable. The laws of physics do not forbid such matter, but whether it exists in sufficient quantities remains unknown. If wormholes could be stabilized, one could theoretically enter at one time and emerge at another. Yet, even if this were possible, causality issues and potential paradoxes make backward travel highly uncertain. It seems to me that the universe has mechanisms, perhaps subtle, to prevent violations of causality, preserving the logical flow of events. Imagine entering a wormhole in your living room and stepping out into Paris in 1920. It is a thrilling idea, but the practicalities, the energy required, the stability of the tunnel, and the potential hazards make it extremely unlikely. Another approach to understanding time travel comes from quantum mechanics. At the smallest scales, the universe behaves probabilistically. Particles can exist in multiple states, and their behavior is governed by probabilities rather than certainties. Some interpretations of quantum mechanics suggest that multiple timelines or parallel universes may exist. In this view, traveling to the past might not change our own history, but could create an alternate timeline. This idea is speculative, but it offers intriguing possibilities for reconciling time travel with the laws of physics. Perhaps every decision we make, every turn we take, creates a branch in the cosmic tree. If we could navigate these branches, we might witness events that never occurred in our original timeline. It is a humbling and exciting thought. It is also important to consider our perception of time. Humans experience time as a continuous flow, but this may be an emergent property of consciousness and the structure of spacetime. Clocks measure intervals, but the passage of time is ultimately a relation between events. One cannot separate time from the processes that unfold within it. Understanding time, therefore, requires both physics and philosophy, for it touches on the fundamental nature of reality. One cannot help but reflect that our awareness of time, our memory, and our anticipation of the future shape the very way we live. Perhaps the true journey through time is not only outward into the cosmos, but inward into our own consciousness. In conclusion, the exploration of time travel and the nature of time challenges our imagination and our understanding of the universe. The laws of physics permit certain possibilities, such as forward time travel through time dilation, and then perhaps even wormholes for backward travel. Though many uncertainties remain, the arrow of time and the increase of entropy anchor us to a flow from past to future, and paradoxes remind us of the constraints nature imposes. It seems to me that the universe allows us to dream of traveling through time, even if the practical realities remain elusive. By studying these questions, we gain insight not only into the workings of the cosmos, but also into the limits of knowledge and the power of human curiosity. We may never build a time machine, but the pursuit of understanding time itself is a journey worth taking. It is a journey that stretches our minds, challenges our assumptions, and illuminates the profound mysteries of existence.